I recently came across a compilation of headlines from the past years, according to which, quote, "Everywhere is warming faster than the rest of the world." This can't possibly be, can it? Unless the rest of the world has left. And I mean, who knows? Have you checked on Uzbekistan lately? In any case, let's have a look. First, let's see whether these headlines actually exist. New England is warming up faster than the rest of the world. Europe is warming twice as fast as the rest of the planet. Canada warming twice as fast as the rest of the world. Israel warming up almost twice as fast as rest of world. Australia is heating up faster than the rest of the world. Car park behind Walmart is warming faster than the rest of the known universe. Just checking if you're listening. China is warming faster than a global average. Africa is warming more and faster than the rest of the world. Middle East heating nearly twice as fast as global average. South Pole warming 3 times faster than the rest of Earth. Finland is warming faster than the rest of the world, and so on. Okay, so the headlines are all real. The next thing to check is whether the headlines are about real papers. The answer is yes. For each of these headlines, there is a scientific publication that's been peer-reviewed or a report from some government institution. The journals are of rather mixed quality, but either way, it seems like contradictory studies are being published in the scientific literature, leading to unnecessarily alarming headlines which claim every part of the world warms faster than the other. That's what it might seem, but there's something else going on, and it's a 2-step explanation. First, there's the question of what the headlines actually mean. Most of the headlines say is warming faster than the rest of the planet, or in some cases faster than the global average. The media takes these two things to mean the same, but colloquially we don't interpret them the same. Suppose you have a forest with trees that are growing. The trees don't all grow at exactly the same speed. Some grow a little faster, some a little slower. If the height is normally distributed, you expect half of the trees to grow faster than average. Okay, but if you pick a particular tree and say it grows faster than the rest of the trees, you'd mean it's actually the fastest, not just faster than average. So this is the first problem with the headlines. They write faster than the rest and mean faster than average. It's then not very surprising that so many countries warm faster than the rest. It's like saying half of Americans are more intelligent than average because that's how averages work. Still, you might say, okay, but then which are the other half of places that are warming slower than average? Pretty much the only place I could not find warming faster in the headlines was New Zealand. And indeed, that gives you a clue. New Zealand is surrounded by water, and the temperature of the water very strongly determines the climate in New Zealand. The thing is that when climate scientists speak of the global average temperature, that includes the temperature of the oceans. But most of the surface of Earth, about 70%, is covered by oceans, and the oceans warm slower than land, basically because they're better at circulating the heat down. So the basic reason that every country seems to be warming faster than the rest of the world is that the rest of the world is water, and land is warming faster than the water. This video from NASA data is a good summary. You can see basically how the hotspots hover over the land areas. Not entirely, of course, but mostly. I'm not sure exactly what lesson to draw from this. The headlines are not wrong exactly, but misleading. The way we would naturally interpret them is not the correct meaning. If I read this region warms faster than the rest of the world, I'd interpret this to mean this region is the fastest warming region of land, and not that it warms faster than the oceans. But then which region of land is the one that does warm the fastest? That'd be the South Pole. And if you look only at populated regions, the fastest warming one is Europe. At least one competition Europe's still winning at. Vladimir Putin's former dissertation supervisor, whose name is also Vladimir, is convinced that oil fields can refill themselves. And now Russia is drilling a hole 8 kilometers into the ground to prove it. If he's right, Russia has a good chance to become the global superpower it always wanted to be. If he's wrong, Russia will have an extremely expensive hole. Let's have a look. The man behind this is Vladimir Litvinenko, rector of St. Petersburg Mining University. He supervised Vladimir Putin's economics dissertation in the 1990s and later ran Putin's presidential campaigns in St. Petersburg. Litvinenko is also a billionaire with close ties to Russia's mineral industry. And for years, he's argued that oil doesn't have to come from fossils. The usual explanation is that oil and gas formed from ancient biological material buried in sediment, heated and transformed over millions of years. Litvinenko instead supports what's called the abiogenic hypothesis. According to this idea, hydrocarbons form from inorganic material much deeper inside Earth, basically due to high pressure, and then they rise through cracks. The important thing is that this geologically produced abiogenic oil can replenish itself in contrast to fossil fuels. We've talked about the abiogenic oil hypothesis previously because it's popular among climate change deniers. The reason is probably that it gives them a reason to question the need for renewable energy. Now, let me be clear. We know that the oil that we currently use is of organic origin. This is because it contains residues from whatever the fossil was that's rotten away, and that can be used to identify the origin of the oil. That said, it's also true that methane as well as oil can be produced by geological processes deep underground if you have enough pressure. In fact, some of the methane bubbles underneath the ocean floor seem to have come about in this way. So abiogenic oil does almost certainly exist. I don't think any scientist questions this. The relevant question is how much and where. Litvinenko is very bullish on the idea. He thinks there is a lot of abiogenic oil and he thinks there's good evidence. At a conference in 2023, he claimed that some oil reservoirs should have been exhausted long ago, but production continues, quote, precisely because the reserves are being replenished. Since I'm already quoting the guy, he's got an entire conspiracy theory about how his pet theory has been suppressed. In an opinion piece from last year, he wrote, "By the end of the 20th century, the theory of the abiogenic origin of hydrocarbons was unreasonably marginalized. The situation was reminiscent of the persecution of geneticists in the Soviet Union from the 1930s to the 1960s. Recent scientific debate gave way to dogmatism. It's possible that the Club of Rome itself needed an apocalyptic forecast for energy resources to justify its policy of global population reduction." He's also said in an interview that pseudo-ecologists who swear by green energy and hysterical voices who proclaim that there's only 20 to 30 years worth of oil left claim that Russia's on the brink of collapse and that this also explains what's happening in the German industry. To make a long story short, he wants to assure Russia its rightful status as world leader by finding infinite oil. Now, Litvinenko is getting the chance to test it. St. Petersburg Mining University says it's drilling an 8 kilometers deep well in Komi, that's a remote oil-producing region west of the Ural Mountains. Normal fossil fuels usually not found that deep underground. It's not unheard of. For example, in China, there are some super deep oil reservoirs, but it's somewhat unusual. You then have to test the oil for organic traces. And most importantly, I guess you want to check whether the reservoir replenishes on timescales less than a few billion years. Oil that never runs out would certainly be useful to Russia. It'd also be useful to oil companies, which is why oil companies have been looking for the great abiogenic oil fields for decades. So far, they haven't found any. Don't get me wrong, I'm not against the Russians drilling holes. Indeed, for what I'm concerned, I wouldn't mind if they spent more time drilling holes and less time threatening the neighbor countries with assimilation. But to me, the entire idea of abiogenic oil looks like a bad case of wishful thinking. Still, an 8-kilometer hole has its uses. If the results arrive, Russia can bury the theory there. A physicist has created a mini-universe in the laboratory and tested the origin of time. This made big headlines a few weeks ago. I didn't intend to talk about this because most of the time the universe and laboratory stories are nonsense, but when I looked at the paper, it was more interesting than I thought. Then I thought about it some more. And, well, here's the summary. Let me begin with explaining why these universe and laboratory headlines annoy me so much. This almost always refers to an ultra-cold gas of atoms that's being made to behave one way or another. For example, the gas expands, and then that's somehow related to the expansion of the universe. Next time I'm bloated, I'm going to write a paper about how this has created a mini-universe. The new paper now is also about an ultra-cold gas of atoms, but the author isn't so much trying to create a mini-universe, he wants to test the origin of time. This work is an interesting contribution to the long-standing question of how to define time in a non-circular way. You can define time as that what's measured by a clock, and a clock as that what measures time. This is not wrong, but it defines neither clock nor time. Now, in Einstein's theory of general relativity, we do have a good definition of time. Time is a coordinate of the four-dimensional differentiable manifold that we live in, and we also have a proper definition for how to define the time that passes for an object in space-time. The problem is, as so often, that quantum physics ruins this, because we know that deep down, all objects are made of atoms and have quantum properties. But how do we define time for them? In quantum physics, time is not an observable. It just can't be calculated. This is known as the problem of time. One of the proposed solutions to this conundrum is to define time from a variable within the system, something about the relations between its parts. If you could do this, then time would be purely relational, an emergent derived quantity, rather than, as in Einstein's theory, a fundamental property of the universe. Concretely, the author of the new paper used about 24,000 ultra-cold rubidium atoms in a trap created by electromagnetic fields and lasers. He split this cloud with a thin barrier of light into two parts. You can think of one part as the part that we observe, say the matter in the universe, and the other part as the environment that we don't observe. This could be, for example, tiny gravitational waves or something else that we usually don't account for. The atoms in the trap oscillate between the two parts, much like a ball will roll back and forth in a dip. Sometimes there are many atoms on one side, sometimes on the other. When the clouds of atoms increases on one side, the author interprets this as an expanding universe. It's an admirably efficient cosmology. No galaxies, no dark matter, just atoms moving left. The key point of the experiment is that you can define an internal time from measuring the entropy of the cloud of atoms on one side. He then shows that this internal time orders the observed events almost as well as laboratory time. This experiment therefore lends support to the idea that time is not fundamental, but emerges from interactions between parts of a system. Or, as the press release put it, scientist creates mini-universe to measure time without a clock. The problem with the idea is that the only thing this experiment shows is that if the number of atoms on one side increases, then so does the entropy suitably defined. How does this have to do anything with the thing that we measure with clocks? It doesn't. So rather than explaining what time is, he shows that it's possible to calculate a quantity that typically increases with the thing we call time, which no one doubted in the first place. I give this paper a 9 out of 10 on the bullshit meter. It's not a 10 because I'm sure the experiment is fine. It's just that the interpretation is complete nonsense. It's nothing to do with either a universe or the origin of time. And this is also why I didn't want to talk about it, because for one thing, I don't like crapping on other people's work, and also it just draws more attention to the nonsense. Personally, I think physicists should worry less about the origin of time and more about the origin of their press releases. Thanks for watching. See you tomorrow.